Welcome to Study Loop.
Hello everyone, today we're doing chapter 23, problem 56, and this problem asks us to determine the reaction conditions, the base, solvent, and temperature needed to convert the ketone A into either B or C via intramolecular alkylation reaction. So in B, we see that we are doing an intramolecular cyclization with this alpha carbon being the nucleophile to do an SN2 backside attack at the electrophile to form this 1, 2, 3, 4, 5, 6, 7-membered ring in B. However, in C, we're using now the other alpha carbon to act as a nucleophile to now do SN2 backside attack at the electrophilic carbon to generate a 5-membered intramolecular ring. So what we're talking about here is for forming the kinetic product of B. So we're forming the kinetic product of B versus the thermodynamic product of C. So obviously, by having the kinetic product of B, we are making the carbanion at the least sterically hindered alpha carbon. So this is going to occur, be faster to form because it's least sterically hindered. However, it's going to be forming a less stable intermediate in the process versus in product C, we're forming the thermodynamic enolate here, in which we will get a 5-membered ring. So in order to favor product B, we need to use conditions that favor kinetic alkylation conditions, and that includes using a big, bulky, sterically hindered base such that it cannot fit in the sterically bulky side. It can only fit in the open side, or the more open side, being this terminal position, and that base is going to be LDA. So LDA is a big, bulky base that's sterically hindered, so it will deprotonate at the least sterically hindered side. And to make sure that we will get deprotonation at this unfavorable site over the favorable carbon, alpha carbon, we will do this reaction in very cold temperatures, minus 70 degrees, in aprotic nonpolar solvent, THF. However, in C, to get the kinetic products, we just need to use any strong base at any temperature really we want. So we can use, for example, sodium ethoxide, which is a strong base, not that bulky, so we can fit in here to deprotonate this. And we can do this at room temperature, and we will use ethanol as our solvent to give us C.